Welcome to E-Padasala lecture series on the subject computer science for the PG postgraduate courses. We are discussing on cryptography and network security. In this topic we are going to discuss about LGAML security, LGAML cryptographic system. The objective of this particular series is to know about LGAML public key crypto system, to learn about LGAML encryption process, to understand the key generation process and example related with the LGAML algorithm. So, we know very well that cryptography basically have two type of encryption, one is symmetric key, another one is asymmetric key. In this asymmetric key, where there are two keys we are using, one is public key, another one is private key. LGAML comes under the asymmetric key cryptography, and here LGAML is a public key crypto system technique was designed by Dr. Tahir LGAML. So, from his name, the name was given to this particular crypto system as LGAML. Here this LGAML depends on the one-way function, means that the encryption and decryptions are done in separate function. So, here suppose I want to encrypt, I have to use encryption function, and similarly for the decryption I have to go for the decryption function. So, this is done with separate encryption and decryption function. LGAML algorithm provides an alternative to RSA, a crypto system which we have discussed earlier for the public key encryption. So, RSA we already done with public key and private key, how the keys are going to be generated, and also the encryption and decryption process with respect to RSA. Now, in this LGAML, the security of RSA depends on difficulty of factoring large number. So, that is what we seen in the case of your RSA algorithm. So, here in the RSA algorithm, where attacker is able to capture the particular information, for example, if he is able to get the public information, but it is very difficult for him to factorize that large integer to know what are the factors in the particular number. But in the case of your LGAML, the security depends on difficulty of computing discrete log in the large prime modulus. So, this algorithm provides the challenge how to compute the discrete logs, whereas this algorithm is challenging about the difficulty of factorization of large integer. So, both are comes under your asymmetric cryptography, but the main thing is how they are handling the encryption process. So, what is the discrete log problem? That is a discrete logarithm. So, usually in asymmetric key cryptography we come out with an exponentiation, modulo exponentiation, that is modular exponentiation for the encryption as well as decryption process. The discrete log is nothing but it is an inverse problem to exponentiation if I having a number modulo of p. So, what is that is, suppose if you are given with a power x, even if you consider an RSA algorithm where we have a power the secret information, it will be generating a ciphertext of mod p. So, if a attacker know a and b, then he can able to get the x. So, as we can able to see that it is an inverse to the exponentiation. So, now we can able to understand here, even though if I know a and b both are public information and mod of p is also known to the attacker, it should be very difficult for him to get back the x. So, that is what we say as an inverse problem to exponentiation, discrete logarithm. So, this is the core concept to make this algorithm withstand even if there is a presence of attack. So, if A is a primitive root, then always exists, otherwise may not. For example, if A is a primitive root, if I am taking that x is equal to log 3 4 mod 13, then has no answer. Similarly, if I have x is equal to log 2 3 mod 13 is equal to 4, where by trying the successive power. So, if A is primitive root, then always exists, otherwise may not. So, now we understand what is this discrete problem. So, the exponentiation is relatively easy, but finding the discrete logarithm is always hard problem. So, it is very difficult to get the log of the exponent value. So, now with this particular idea, your Elgamal crypto system is able to design the encryption algorithm. So, it is based on the 2 modular exponentiation. So, even though we can consider, but the Elgamal has disadvantage that the ciphertext is twice as long as the plain text. So, ciphertext is, we can able to see that the ciphertext is twice as long as the plain text, where this is not the case with respect to your RSA. So, when I have the ciphertext of size 8 bit, plain text of size 8 bit, then my ciphertext will be 16 bit. But it has the advantage that even if we have same plain text, for example hello, it gives different ciphertext at each time it is encrypted, right. So, there is a disadvantage of this particular crypto system, that is when I do an encryption, always I am going to get the size is doubled of the plain text, the ciphertext is going to be twice as long as the plain text. Even though it is a disadvantage, but there is an advantage that each and every time if I go for encrypting a plain text, it is not going to give me the same ciphertext, but each and every time the same plain text gives different ciphertext. So, that is the advantage of your Elgamal crypto system. So, now we are looking into the overall process of this particular algorithm. Suppose there are 2 users Alice and Bob, they want to exchange some information, that is the P, the plain text. So, they want to send this message confidentially to Bob. So, I want to Alice want to send a message confidentially to Bob. So, using this Elgamal crypto system, how it is going to do the particular process. So, now we can able to see there is a channel between your Alice and Bob, and this channel is going to be tunneled, or it is going to be covered with to protect the information from the attacker. So, as we can able to see that there are ciphertext, 2 ciphertext C1 and C2. So, here you can able to see that the public information what is going to be shared between your Alice and Bob here is E1, E2 and P. So, this public key where it is going to be shared between Alice and Bob, suppose Alice want to send a Bob message, then this is the public key of Alice. So, as we know the symmetric key, asymmetric cryptography, if suppose a person want to send a message to another person, first thing he should get the public key of that person. Suppose Alice want to send a message to Bob, Alice needs Bob's public key. Bob will do the key generation by selecting very large prime number and a primitive root, that is your P and E1, and then one secret information D is going to be known to only Bob, nobody else. So, Bob only choose that particular value D, and also the value is going to be kept secret. Now, Bob will generate the public key. How he is generating the public key? E2 is equal to E1 power D mod P. So, already he know E1 where it is selected by Bob, and based on that E1 and D and P, it is generating E. As we can able to observe here, the D is the private key, D is the private key of Bob, whereas E1 E2 and P are public. That means anyone, not only Alice, anybody from the world, they want to send a message to Bob, they can get the public key from Bob and they can able to generate that. So now the idea here is both the keys are generated, private key and public key. Now the Bob has to give the key to the Alice so that she can able to communicate with Bob with the public key. So now this key is used for encryption process. So here you can able to see that now P is the plain text, actually Alice want to send to Bob, and to generate the ciphertext they have to use the public key of Bob. So now the key is taken from Bob and they are generating C1 and C2, C1 and C2. So this E1 power mod P is equal to C1 and E2 power R into plain text. Here only they are using the plain text mod P, they are generating the C2. Now this C1 and C2 are transmitted over the channel and it is reaching the Bob's system. In the Bob's system it is going for decryption process where it has the private key. So decryption is only done with the private key. So already he received C1 and C2, now he is going for decrypting the information with the help of the private key. So for the decryption process, C2 into C1 power D inverse mod P. So now it get back the original message. So this is what the overall process where, so now we can able to see how they are generating the key. So as we know there are two keys, one is your public key, another one is a private key. Already we know that Bob has to generate two keys, similarly Alice also need to generate the two keys. How to generate the public key as well as the private key? So first thing they need to select a large prime number and then select the D. So for example here member of a group such that D lies between your 1 and P minus 2. So it is very important that the D value should be a member of a group where ZP star comma the operator, where your D must be within the range 1 to P minus 1, P minus 2. Now again he has to select a primitive root in the group. So this primitive root is given by E1 and then from that it is going to be generating E2, that is E1 power D, because here this E2 is going to be sent to the person who want to send the particular message. So now D is kept as the private key and E1, E2, P are the public key. So here you can able to see that we need to announce the public key, you need to announce the public key to everyone, whereas the D should be kept secret. So D is the member of group and E1 is a primitive root, from that it is generating E2 where you can able to send that particular message to. So A must do the following: generate a large prime number P and a generator A, and they have to choose the secret. So these steps where they have done with the previous algorithm, then they have to go for computing D where X is our private like your previous case. After that they have to go for the encryption process. As the encryption, there is one additional step where we have here is random integer. This random integer in the group where it is used for generating the C1. So Bob is sending E1 and E2, Alice need to generate C1 with the help of E1 where it is choosing a random integer R in the particular group where already they are used, agreed between your Alice and Bob. Now they are going to generate C2 from P into E2 where E2 is also sent by Bob to Alice, that is using that the random integer r, where it is providing two ciphertext C1 and C2. On the decryption side, already we know C2 into C1 power d inverse mod p will give the plain text. C1 and C2 are sent by Alice to Bob, where now the Bob can generate its own private key. So, now we work out with an example. Let us assume that p is equal to 11, that is, here we are considering very small prime number, but actually in practical it may choose a prime number in the 300 digit of size. So, now we are considering the prime number as 11 and a is equal to 2 and x is equal to 5. So, what is this? A is your generator and x is your secret information. So, now I am going to, so according to this we need to use a generator for choosing the particular value. So, here d is equal to 2 power 5 mod 11 is equal to 10. That means I am calculating the, already we know x is the secret information, that is going to be kept in the receiver side, whereas at the sender side I need to share the information 10, that is your E2, E1 and P. So, E2, E1 and P has been sent publicly, whereas the private key 5 is going to be kept from the receiver side, secret. So, here we are taken A as a generator for generating the E2, right. In this case, how you are going to select a number whether it is going to be a generator or not. So, as this case we are taken A as the generator, how we are deciding on A, right. So, these steps will explain you how to choose a generator, such a way that it must be between 1 and p minus 1. So, first step we need to select the value between 1 and p minus 1, and then we have to find phi is equal to p minus 1, and we find all the factors of phi f1, f2 up to fn. Then we go for finding that q1, q2, qn, whereas qi is equal to fi for the redundant factors. Then we will go for identifying that qi is equal to fi frequent, that is where you can able to use it for generating. So, when I want to say that particular number is a generator, if and only if wi is equal to a power phi divided by qi mod p, it is not equal to 1 for all qi. So, now let us look into this particular example. So, according to the particular steps given here, first thing I need to choose the prime number p. So, that is we need to choose a value between your 1 and p minus 1. So, here 11, that means be 1 to 10, I need to choose a value 1 to 10. So, assume that I am taking a value a is equal to 2. Here I want to test a is a generated number or not. So, based on the previous step, I need to find out that phi of p minus 1, that is your second step. Phi of, I want to know what is the value for phi in order to p minus 1. So, here phi of p minus 1, that is 10, the factor of 10 is 2 comma 5, it is Euler's Taussian function or Euler's phi function. We can apply that, we can able to find out what are the factors of 10. So, we got 2 and 5. Now, we have q1 is equal to 2, q2 is equal to 5. So, based on the last step, wi is equal to a power phi of phi divided by qi mod p. So, now what I have to do here is I need to find out w1 and w2, because we know there is q1 and q2. So, first I will take a of phi divided by qi. that is here A of phi divided by q1, already we know the phi is 10, that is p minus 1, phi is equal to p is 11. If I want to find out phi of p, that is 10, and their factors of 10 are 2 comma 5. So now I want to find out W1 and W2. So A is phi divided by q1, that is 2 mod 11. Now I am getting 10, which is not equal to 1. Similarly, I do it for q2 value, that is W2 is equal to A power phi divided by Fi q2. So that is your factor, it is find Fi, that is your F factor 2. Now I will know I can able to get the value mod 11 is equal to 4, which is also not equal. So according to the final step, when it is not equal to 1, then we can say that the number A which I have chosen here is a generator. So now A is equal to 2, when P is equal to 11, then A is a generator, because according to this, which is not equal to 1, we can say A is the generator. Similarly, if I am going to take the case where A is equal to 3, if I want to test whether A is equal to 3 is a generator number or not. So now I am doing the same series of tests. First I will find out phi of P, that is P, phi of P is P minus 1 is equal to 10, and factor already we know that is 2 comma 5. Now q1 is equal to 2 and q2 is equal to 5. 3 power W1 is 3 power 5 divided by 2, 3 power 5, that is 10 divided by 5. So mod 11. So now we can able to see that the first value, that is q1, where you are getting 1, then this is not a generator. Even though here it is not equal to 1, but this case if this is equal to 1, then it is not a generator number. So like that we have to find the generator. Similarly, you can also do it for 41, where A is given and here it is not equal to 1, then we can say this is a generator number. So if I am able to get the generator number, from that I can able to E1 and E2. According to now, the public key is P, A and D. From the receiver it is received. So now you have to choose a random integer k, such that it is lies between your 1 and P minus 2. So here is represent the plain text as an integer m, whereas the value is 0 P minus 1. Now we have to compute the following, where y is equal to a power k mod p and z is equal to d power k into m mod p. So finding the cipher text as follows: c is equal to y comma z. Now we got the cipher text C1 and C2, that is equal to y comma z. So sender sends the cipher text to receiver A. So the same steps are going to be repeated. Now we can able to see that after receiving this particular value, it can able to recompute it. Now we will look into the example. Let us assume that the two persons are going to send a message with the help of this public key and the private key. If Alice and Bob want to send a message with the public key and private key, already they have been done the computation. Now they got the key 11, 2, 10 are the public key and private key is 5. As we assume here, the plain text is going to be shared between Alice and Bob is H, AGE. So AGE is the plain text where Alice want to share with Bob. It is represented as 1, 7 and 5. So according to the alphabet position A, B, C, D, E, F, like that we are taking here is 1, 7 and 5. If we assume here our integer value for the plain text is given as A, for A is equal to 1, G is equal to 7 and E is equal to 5. Now the encryption, where it is choosing some random integer k is equal to 6. So we are able to compute y a, that is the message where it need to send as the first cipher text. This is your C1, that is 2 power 6 mod 11 What is that? 2? 2 is the generator number. So, now we can understand what is the need for this generator. We already know that always in the cryptography we choose the largest prime numbers, but in this LGAML we have an additional one number, not like in our RSA where you have a generator number. So, now we can able to see that during the encryption process C1 is selected as 9. Now, it is going for encrypting the letter A, that is plain text A is equal to 1. So, 10 to the power 6 into 1 mod 11 where you are getting the Z A, that is nothing but C2. Similarly, I can choose a random integer k is equal to 4. Now, I will go for the next letter is G. This is our first letter A where it is equal to 1. Next letter is G which is equal to 7. Again we can able to see that there is a generation of random integer. They are choosing a random integer for the next letter k is equal to 4. Previously k is equal to 6 for the first letter. For the second letter they are choosing k is equal to 4, and third letter they are choosing k is equal to 7. Now, we are generating the next C1 and C2 where 2 power, that is your generator 2 power 4 mod 11 is equal to 5, and C2 that is your Z is equal to 10 to power 4 into the plain text A G mod 11 is equal to 7. Similarly, it is also doing for the third letter, that is your E, that is your H A G E. So, here it is YE is equal to 2 power 7 mod 11, it is 7, and similarly ZE is 10 power 7 into 5 mod 11 is equal to 6. Now, Alice is ready with 3 set of ciphertexts C1 C2, C1 C2, C1 C2. For the first letter A 9 comma 1, second letter 5 comma, that is our G, and third letter 7 comma 6, that is for E H. So, now he is going to send this particular information to Bob. After receiving that, they go for the decryption process of the ciphertext as follows. Here they need to compute R and M where R is equal to Y P minus 1 minus X mod P, and also M is equal to R into Z mod P. So, now we can able to see that 9 power 11 minus 1 minus 5 mod 11 is equal to 1, M 1 is equal to, that is your 1 into 1 mod 1, that is mod 11 is 1. So, now I got the letter A. Similarly, I do for the letter G and also letter E. So, after doing this particular process where I can able to get the original plain text was sent from Alice to Bob is 1, 7 and 5. The letters of this plain text are H, A, G, E. So, what we can able to understand from this particular crypto system is, in Elgamal public key crypto system, it is also a category of your asymmetric crypto system, and here it is sending the ciphertext twice at that of your plain text. But the advantage of Elgamal where we consider that is, each and every time we try to generate the ciphertext for the same plain text, we get different ciphertext. In addition to that, we also understand about the generator, what is the purpose of generator, how would the generator is playing a role in the case of your encryption as well as the decryption process. Thank you.